Hello students, in today's lecture we shall discuss what are the various methods of speed control of DC motor. You recall the equation that we discussed earlier relating speed and torque. So speed depends on voltage, the flux produced by the field winding and the armature circuit resistance. So obviously there are three methods that you can think of. The first is armature voltage control, that is we change the voltage applied across the armature. The second method is the field control or field flux control, where we shall vary the flux produced by the field winding by varying the current flowing through the field winding. So this method is the field flux control, and the third method is somehow we vary the resistance of the armature circuit. That can be done by inserting some external resistance in series with the armature, and that resistance can be varied to vary the speed of a DC motor. So let us now discuss briefly the three methods here. The first method is armature voltage control. Now you can see this equation. If we vary the voltage across the armature, keeping the flux constant, that is we shall give field winding a separate supply so that the field flux is constant. We only vary the armature voltage. So if we vary the armature voltage, you can see from this equation the no load speed y-intercept will change. The slope of the characteristic is not affected. Ra upon K phi square remains constant. So the characteristic will shift parallel to itself downward if you decrease the voltage. For rated voltage, this is the characteristics. For voltage V1, which is less than VR, this is the characteristics. And for voltage V2, which is less than V1, this is the characteristics. So the characteristic shifts parallel to itself. And if you are supplying a constant torque load like this GL, then the intersection of this load characteristics and the motor characteristic will give you the operating point. So the three operating points at this point, speed will be omega mr, the speed at rated voltage. At voltage V1 speed is omega m1, and at voltage V2 speed is omega m2. So you can see that you can vary the speed over the whole range, starting from the rated voltage, rated speed to a very low speed, close to zero. So this is what is the armature voltage control. Similarly, in the case of a series motor also, if you vary the voltage across the armature, the characteristic shifts downwards and the speed will change from omega m1 to omega mr to omega m1 to omega m2. So in this way you can control the speed over the whole range, that is starting from the rated speed to a very low speed. Now one precaution you have to take here, that voltage should be changed only in small steps, or it should be changed very gradually. So otherwise what will happen, the current that the motor will draw in the transient will be very high, and that may damage the commutator brush segments. So suppose this is the voltage V2 and you are operating here, and suddenly you have increased the voltage from V2 to VR in a large step. Then what will happen? As soon as we change the voltage, the current drawn by the motor will change. That is V minus E upon RA. Speed will not change instantaneously because it has some high mechanical time constant. It will take some time. So immediately what will happen? The current will change. Current will change means this is the characteristic speed versus torque, as well as the speed versus current characteristic, same nature. So what will happen? The characteristic is somewhat like this, and the speed will be the current drawn by the motor will be very high. That is not safe for the motor. So you have to change the voltage only gradually, so that the current remains within the permissible limits. So this you have to do in small steps, or you can change the voltage gradually so that the current is maintained within the safe limits. So this precaution you have to take. Now what are the advantages of this method. First advantage is visible from these characteristics, that the nature of the speed torque characteristic is not affected. That is, for example, you are using a separating circuit DC motor, and the requirement is that it should have a good speed regulation. That is, the speed should not change much with the change in torque. So this nature of the characteristic of the motor is maintained. So the speed regulation still remains same. That is, the change in speed from no load to full load is not affected. It remains same as it was for the original voltage or the rated voltage. So this is one of the advantages of armature voltage control. Second advantage is that the torque capability of the motor is not affected. The torque produced by the motor, if you recall, it is given by T equal to Ke phi into Ia. We are keeping this phi constant, so the torque produced by the motor remains constant. At you can draw a continuous rated current by the armature, so the torque produced will be the rated torque. So this means that if you are reducing the voltage, flux is remaining constant, and you can always allow the rated current to flow. So the torque that the motor can produce is always equal to rated torque. So the rated torque can already be produced. So the motor is said to be a constant torque drive. This drive is said to be a constant torque drive. So torque capability is not affected. You will see in the other methods, the torque capability reduces as we reduce or as we change the speed of the motor. So these are two main advantages of this method, and that is why this method is most commonly used method. The limitation here is that you cannot, if you want to increase the speed above the rated speed, this method cannot be used, because you cannot raise the voltage above the rated voltage to any substantial level. Only slightly you can increase, maybe 10% or 20%, that may be permissible, but usually we try to keep the voltage below the rated voltage. So speed control cannot be done above the rated speed. So there is limitation of this method. If you have to go for speed control above the rated speed, then you have to think of some other method. Now, how to implement this method? What are the ways you can implement the armature voltage control? Because here you must remember that you have to control the voltage at a high current across the armature. The armature draws a high current. So you have to have a variable voltage supply that is capable of operating at high current also. High powered system is required there. So the one method is Bode-Leonard scheme. So this has been used in for many years, and now it is being replaced by static methods. In this method, what we do, we shall discuss these methods in detail in the coming lectures. But basically, you must understand that what is this Bode-Leonard scheme. To run the motor, we require a variable voltage supply. For that, we use a DC generator. A DC generator is used, and that DC generator is run by some prime mover. Usually, we use 3-phase induction motor that runs the generator, and the field of that generator is varied to vary the voltage across the generator, and that variable voltage is given to the DC motor to control the speed. So this method, although it is very costly, because to run the motor you require 2 additional machines, one generator of same power rating and one motor of same power rating. So the scheme is very costly, as well as it requires more space, more floor area is required. You require triple the floor area required by that motor, of which you are controlling the speed. But earlier there was no other method, so this method was being used extensively in the industrial applications. Now, if you want to avoid this, there are other options also. Nowadays it is available now that you can have a tap changing transformer followed by some uncontrolled rectifier, that is diode bridge. So voltage can be varied by varying the types of the transformer. So voltage control is achieved from there, and then that AC voltage is converted into DC voltage by the diode bridge, and that voltage is fed to the DC motor. Third method that you can use is, you can use, instead of using tap changing transformer, you can use a controlled rectifier where you are using thyristor bridge, where you can change the firing angle, the thyristors, to change the average output voltage available across the thyristor bridge, and that voltage is given to the DC motor to control the speed. And in case the supply is DC, you have another option that you can have a chopper or DC to DC converter, where by changing the duty ratio of the chopper, you can change the average output voltage, and hence you can change the speed of the motor. So these are the three methods. We shall discuss in detail the method control rectifier method and chopper control method. So these methods we shall discuss in detail in the coming lectures. So that is all for this lecture. In the next lecture we shall discuss the other two methods, that is field control and armature resistance control, and then we shall compare these methods, their advantages and disadvantages. Thank you for today.